How much work is required to move a negative 100 microcoulomb charge from an electric potential of negative 50 volt to 250 volt? If the charge accelerates from rest, what is going to be the final speed if it has a mass of 0.001 grams? So the first thing I need to do, we know work is going to be equal to negative Q times delta V. W is work, Q is the charge, and delta V is the potential, electric potential difference. So we need to find out work. Q is negative 100 times 10 to the power of negative 6, because I need to convert microcoulomb to coulomb. And delta V is V2 minus V1. So it's going to be 250 minus negative 50. So it's going to be negative times negative positive 100 times 10 to the power of negative 6 times 300. So that will be 300 times 100 times 10 to the power of negative 6. That's going to give me 0.03. Now, in order to find the final velocity, we know W equal to change in kinetic energy, which is going to be kinetic energy final minus kinetic energy initial. Since it says the charge starts from rest, it means that the initial kinetic energy was 0. So work equals to the final kinetic energy. So kinetic energy is 1 over 2 m times final velocity squared, because we're talking about final kinetic energy. So that's going to be 0.03. 1 over 2, m is 0.001 Vf squared. So that's going to be Vf squared 0.06 divided by 0.001. It's going to be 60. So Vf is going to be square root of 60. That's going to be 7.746 meters per second.